Alright, now that we've gotten a centered sum of squares and cross products matrix, and we've talked about division by a scalar in videos 3.8 and 3.9.1 respectively, we are going to convert the CSSCP matrix to a variance or covariance matrix, which we just actually call a covariance matrix. Now, as a reminder, this is the formula for variance, and this is the formula for covariance. We got both of these, the numerators, in video 3.8, which we demonstrated on Excel, and we came up with this resultant matrix. So remember, 46 and 50 would be the numerator for variance, the sums of squares, and your numerator for covariance, the sums of products, is 43. Now, this n minus 1 is the degrees of freedom. So in our previous example, let's go back here. We had two variables, right, and each one had five observations. So n is our number of observations, and you subtract that by 1. So in our previous example, our degrees of freedom would be 4. So n minus 1, n was 5, it's 4. Okay. So let's get a matrix C, meaning covariance matrix. And if you remember from video 3.9, we have to multiply the matrix by the inverse of the degrees of freedom. So once again, our degrees of freedom is 4. So the inverse of that is 1 over 4. And we multiply this by the matrix that we had previously that we got in video 3.8b. So this will be 1 over 4 times our matrix of 46, 43, 43, and 50. And you get 11.5, 10.75, 10.75, and 12.5. And this is your covariance matrix. So once again, what we did, we took the matrix that we got previously, which was the numerator here of both of these, 46 and 50 being the numerator variance and 43 being the covariance. And we have to divide that by n minus 1. To divide that by the degrees of freedom, which we found to be 4, you just multiply it by the inverse of the degrees of freedom. So multiply it by 1 over 4, and you get your covariance matrix, which contains your covariance, 10.75, and your variance of 11.5 and also 12.5. Now we can check this to make sure we did it correctly. So let's check it. And let's take the variance of x. So you get the sums of squares of x, which, if let's go back to Excel so we can look at what our deviation scores here were. So we get 5 squared plus 2 squared plus negative 2 squared plus negative 2 squared plus negative 3 squared over our degrees of freedom, 5 minus 1. So that will turn out to be 46 over 4. Remember, 46 over degrees of freedom 4, and we get 11.5. So that matches with that one. Let's do the variance of y. You get 6 squared plus 0 squared plus negative 2 squared, negative 3 squared, negative 1 squared. That's over degrees of freedom, and we get 50 over 4, which is 12.5, which matches here. And lastly, on the off diagonal, we get the covariance of x and y. the sum of products of x and y over degrees of freedom. So we get 5 times 6, 2 times 0, plus negative 2 times negative 2, negative 2 times negative 3, plus negative 3 times negative 1. All that over our degrees of freedom. This is going to equal 43 over 4, which is 10.75, which matches what we had up here for covariance. Now let's do this in Excel. So I left what we had in video 3.8. I'm going to combine, we didn't do 3.9 in Excel, but I'm going to combine that here. So let's have our covariance matrix C is 1 over 4 times our matrix B, which we have here. So once again, that's the inverse of the degrees of freedom. So let's highlight this here. Equals 1/4 times, highlight this matrix, close your parenthesis, Control Shift Enter, and it's the same, it just rounded here, 10.75 to 10.8, but that's how you do it. Once again, this is a demonstration of division by a scalar. We're dividing matrix B by the inverse of the scalar 4, so degrees of freedom 4. And that's how you get your covariance matrix, which is going to come in handy